So good evening, welcome to SAKALAVIDYA YouTube channel. Once again, welcome to the evening session. Okay, Dasari Chaitanya, Balu, Swati, Kartik, Dishwank, good evening. Good evening all, good evening. Pushpa, Surya, okay. Abhiprakash, Govind, okay. Laddu Prasad, Swati, Suma, Vijay, Damodar Reddy, Nageshwar Rao, Pavan, Dasari, okay, Bittu, Ravindra Kumar. Thank you, thank you, thank you, thank you. Okay, let us start now. Right. Binomial theorem, part 9. Okay, question number 74, I think so. 74. C0 plus 2C1 plus 3C2 plus so on dash dash n plus 1 Cn equals to, first option, n plus 2 times 2 power n, second, n times 2 power n, third, n times 2 power n minus 1, fourth, n plus 2 times 2 power n minus 1. This is the question. Okay, good evening all. Right, so now this question can be done both ways. By verification of the options can be done, otherwise we have one shortcut. Let me do the shortcut for that one. So what is the shortcut means? So we have one shortcut. This is a times C naught plus a plus d. That means this is C1. Next term is just like arithmetic progression, a plus 2d C2, okay, and so on. This equal to plus a plus nd Cn is equal to, we can write coefficient of C naught plus coefficient of Cn upon 2 multiplied with 2 to the power of n. This is the shortcut you can apply. That means if the coefficients are in arithmetic progression, so then we can apply this shortcut. For example, coefficients C a plus d, a plus 2d and so on, a plus nd are the actually here terms of a arithmetic progression. Then we can write coefficient of C naught, this one, plus coefficient of Cn, a plus nd by 2 multiplied by 2 to the power of n, we can write it. Observe now in the problem, this is actually 1 into C naught, 1 plus 1 2, 2 plus 1 3 and so on n plus 1. Coefficients are in arithmetic progression. So that's why if you say this s, summation value s, coefficient of C naught 1 plus coefficient of Cn is n plus 1 upon 2 multiplied by 2 power n. This we can write n plus 2 upon 2 multiplied by 2 power n. This equals to n plus 2 times 2 power n by 2 means a to the power of m by a to the power of n is a to the power of m minus 1. This we can write 2 to the power of n minus 1. That means fourth option is the right option. Fourth option is the right option. Right. Problem number 75. 75th problem. If n greater than or equal to 2, then 3 times C1 minus 4 times C2, C2 means NC2, yes, C1 means NC1 with usual notation. Okay, welcome, plus 5C3 minus so on dash dash plus minus 1 to the power of n minus 1 of n plus 2 Cn. First option minus 1, second option 2, third option minus 2, fourth option is 1. Okay. So this series, let us say S equals to 3 times C1 minus 4 times C2 plus 5 times C3 and minus dash dash so on plus minus 1 raised to n minus 1 of n plus 2 Cn. This is actually incomplete series. There should be C naught. So first we need to find out C naught. C naught means here put n is equal to, that means first term we need to find out. First term. So first term equals to, we can write minus 1 to the power of n minus 1 of n plus 2 Cn when n is equal to 0. So this equal to minus 1 to the power of, here minus 1, this is n is 0, 2 times Cn. Minus 1 to the power of minus 1 means 1 by minus 1. This equals to minus 2 C naught, minus 2 C naught. That means add minus 2 C naught on both sides. So add minus 2 C naught on both sides. See, having been added minus 2 C naught on both sides, we get like this. S minus 2 C naught plus, sorry, 1 minute, equals to minus 2 C naught plus 3 C1 minus 4 C2 plus 5 C3 and minus and so on plus minus 1 to the power of n minus 1 n plus 2 times Cn. It's very interesting that actually this is from minus 2 C naught to plus 3 C1 and so on up to this one. Alternative sign change is there, or even you can apply sigma value. This value will be, total value will be, you will be getting 0. This will be 0. So that's why we can write now S minus 2 C naught. C naught means, we remember, C naught is nothing but NC0. NC0 is nothing but 1. So this is nothing but 2. S minus 2 is equal to 0. We require S value is 2. So second option is the right option. Second option is the right option. Now go through it, this problem. Okay. Next, let us move to the 76th problem. 76th problem. 76th. Okay. C1 upon C0 plus 2C2 upon C1 plus 3C3 upon C2 plus so on dash dash plus n times Cn upon Cn minus 1 equals to, okay, first option is n plus 1 times n plus 2 upon 2. Second, n times n plus 1 upon 2. Third one, n times n minus 1 upon 2. Fourth one, n times n plus 2 upon 2. Okay. Here one interesting formula we have. Let me revise that one. NCR upon NCR minus 1. We know that here n minus of r minus 1 by this r we can write. So this equals to n minus of r minus 1 by r. Okay. With this basic fact we need to apply in each term, we get our answer. So this is the formula we need to apply. Understood now? So that's why let us come to the problem now. Solution. Say yes, it's complete series. S equal to C1 by C0. This is NC1 by NC0. N minus 0 by 1. N by 1 plus 2 times we can write this is n minus 1 upon 2 plus this will be written 3 times n minus 2 upon 3 plus so on dash dash plus n times we can write n minus, here see n minus n minus 1, this is nothing but 1, n times 1 by this n. So now n gets cancelled, 3 gets cancelled, 2 gets cancelled, and reverse order write down. You have 1 plus 2 plus 3 plus dash dash nothing but plus n. This is nothing but sigma n. Sigma n is equal to sum of the first n natural numbers. Sum of the first n natural numbers is given by n times n plus 1 by 2. So second option is the right option. Second option is the right option. Okay, next 77. Problem number 77. 2C0 plus 2 square C1 upon 2 plus 2 cube C2 upon 3 plus so on dash dash 2 to the power of n minus 1 into Cn upon n plus 1 equals to, right, first option 3 raised to n plus 1 minus 1 2 times n plus 1 Second one, 3 raised to n plus 1 minus 1 upon n plus 1. Third one, 3 raised to n minus 1 upon n plus 1. Fourth one, 3 raised to n plus 1 upon n plus 1. For example, these kind of problems are easily we can do in the examination. Right? So better you substitute n is equal to something 2 or 3 like that. For example, if you say 2, you need to consider the first 3 terms left hand side and verify the options. So let us do like this substitution method. So first you divide like this. First LHS or given expression, right? Okay, take it. Given expression. C, put n is equal to 2. That means you get like this 2 times 2c naught plus 2 square times 2c1 by 2 plus 2 cube 2c2 upon 3. See, 2c naught is 1, so 2 plus 2 square into 2c1 is 2, 2 by 2 is 1 plus 2 cube times this is 2c2, 2c2 is 1, 1 by 3. So this equals to 2 plus 4 plus 8 by 3. 6 plus 8 by 3. This is 26 by 3. So let us check the simplification once again. Let us check the simplification once again. So 2c naught is 1, 2 into 1, 2. 2c1 is 2, 2 by 2 is cancelled, 2 square into 1 plus 2 cube into 2c2 is 1, 1 by 3, 8 by 3. This is 4 plus 2, 6 plus 8 by 3, 3 LCM, 18 plus 8 is 26 by 3. So now check the first option. First option n is equal to 2, we need to substitute 3 cube minus 1 upon 2 times 3. 3 cube is 27 minus 1 by upon 6. This is 26 by 6. It's wrong. Go to second option. 3 cube minus 1 upon 2 plus 1 is 3. 26 by 3. Okay, second option. Third option also let us try. 3 cube. 3 cube is, sorry, this is 3 power 4. This also 3 power 4 you will be getting. 81 minus 80 by 6. 80 by 6. This will be 3 power 4. 3 power 4 means 80 by 3. So first option, second option deleted. Third option, 3 cube. 27 minus 1, 2 plus 1, 3. 26 by 3. That means third option is the right option. Third option is the right option. So go back and come, Mr. Venkateshwar. Actually, I think your network is very good. Okay. Right. I will do once again. We need to check once again options. I will check first option. 3 power 4 minus 1, 2 times 3. 2 plus 1 is 3. 81 minus 1, 6. 80 by 6. That is 40 by 3. No, it's not equal to 26 by 3. Now okay, n is equal to how much? 2. 3 cube minus 1 by 2 into 3. 3 cube is 27 minus 1 by 6. 26 by 6 is not equal. Second option, 3 cube minus 1 by 2 plus 1 is 3. So 26 by 3. Third option is 3 square. 3 square is 9 minus 1 by 3. 8 by 3. So that means second option is the right option. So not third option. Yes. Not third option. Yes, second option is correct option. Absolutely correct. So we need to check carefully. Right. 78. 78. 78. Yes. If n is an even integer, if n is an even integer, then 1 upon 1 factorial by n minus 1 factorial plus 1 upon 3 factorial by n minus 3 factorial plus 1 upon 5 factorial by n minus 5 factorial plus so on dash dash 1 upon n minus 1 factorial to 1 factorial, or you can write 1 factorial equals to so first option is 2 raised to n upon n factorial, second 2 raised to n minus 1 factorial, third one is 2 to the power of n minus 1 upon n factorial, fourth one is 2 to the power of n minus 1 by n minus 1 factorial. This is the question. Right. Okay. Right now, seventy-eight. Solution. Let us say S equals to required sum 1 upon 1 factorial n minus 1 factorial plus 1 upon 3 factorial and n minus 3 factorial plus 1 upon 5 factorial and n minus 5 factorial plus so on dash dash 1 upon n minus 1 factorial and 1 factorial. Yes, here actually you remember first multiply both numerator and denominator of right hand side with n factorial. Multiply both numerator and denominator of RHS right hand side with n factorial. So that means this can be written like this: 1 upon n factorial times, we can write n factorial by 1 factorial into n minus 1 factorial plus n factorial by 3 factorial into n minus 3 factorial plus n factorial by 5 factorial into n minus 5 factorial plus so on dash dash n factorial upon n minus 1 factorial into 1 factorial. So we have one basic formula. So what is the basic formula we have? NCR equals to n factorial by n minus r factorial into r factorial. Okay. So right, one thing I will do it. Just now I will do. Yes. Right now. Right now. Welcome, welcome. So now we can write this is equal to 1 upon n factorial. So this is nothing but NC1. See, NC1 means n factorial by n minus 1 factorial and 1 factorial plus this is NC3 plus NC5 so on dash dash plus NCN this is. So this is actually sum of the coefficients of the odd powers of x this is. Yes, NC1 plus NC3 plus NC5 NCN this is equal to 2 power n minus 1. So this is 2 power n minus 1 upon n factorial. This is the answer. 2 to the power of n minus 1 by n factorial. Okay. Right. Next. Second option is the right option. 79. 79. 79. Okay, this is NC n minus 1, correct? Right. '79. If 1 plus x square whole to the power of n equals to sigma r is equal to 0 to 2n ar x to the power of r, then right, then a1 minus 2a2 plus 3a3 minus and so on dash dash plus 2n a2n equals to first option 0, second option 1, third option is n, fourth option is minus n. Fourth option is minus n. Right. So now 1 plus x square whole to the power of n expansion is equal to sigma r is equal to 0 to n a r x to the power of r. First, let us expand this one and equate it to 1 plus x square whole to the power of, okay, later I will explain definitely, whole to the power of n. So this we can write like this: a naught x to the power of 0 is 1 plus a1 x plus a2 x square plus so on dash dash plus a2n x to the power of 2n is equal to 1 plus x square whole to the power of n. This just I expanded, that's all. So now you want to get 2 and 3 means x differentiation is actually 1, x square differentiation is 2x, 2a2 you will get, even a3 is also write down, a3 x cube plus. So differentiate both sides with respect to x, okay. Differentiating both sides with respect to x, we get a naught is constant differentiation 0, x differentiation 1, you get a1, x square differentiation is 2x, 2a2x, you get x cube differentiation 3x square, 3a3x square plus so on dash dash. This will be 2n times a2n x to the power of 2n minus 1 equals to, now the differentiation of right hand side need to be written. This is also in the form of x to the power of n, so that we can write n times 1 plus x square Okay, welcome back to the session. Actually, due to the power cut, I was not able to continue the classes, but I will. Now I think you will be getting, everybody. Okay. So that Krishnavamshi is my ID. Due to power cut, actually, even I was able to convince you through my mobile data. Okay, right. So anything is there, actually I will give through my ID, that is Krishnavamshi. My ID is, please do remember, right. So today I will complete 2 or 3 problems, right. Let it be done. One minute. Okay. What is the question number? Anybody tell me now. I need to refer once again. I go for the problem. What is the question number? But I need to write once again. Anybody? 79. Okay. 79. So I need to discuss the solution, I think so. Okay, solution. This a naught x to the power of 0 plus a1 x plus a2 x square plus so on dash dash, or is last value is n, a to n x to the power of 2n equals to, okay, 1 plus x plus x square all to the power of n. Differentiate both sides with respect to x. So now we get a0 differentiation 0. This is a1 plus 2a2 x square plus similarly 3a3 x square you will be getting, and so on dash dash, 2n a 2n x to the power of 2n minus 1 equals to 1 plus x square whole to the power of n. Differentiation is n times 1 plus x square whole to the power of n minus 1 into 1 plus x square differentiation. 1 differentiation 0, x differentiation 1, x square differentiation 2x. Now what we need to get it now? a1 minus 2a2. That means now put x is equal to minus 1 both sides. If you put x is equal to minus 1, you get like this: a1 plus 2a2 into minus 1 minus 2a2 plus 3a3 minus 1 square plus minus dash dash here plus, because this is even power, 2n into a to n you will be getting equals to n times 1 minus 1 plus 1 whole to the power of n minus 1 and 1 minus 2. Okay, this will be now n times 1 gets cancelled, 1 to the power of something 1, n times minus 1 whose value equal to minus n. Understood now? That means fourth option is the right option. Option 4. Because I don't have that previous question, because that might have not saved, so you need to tick in your notebook. Problem number 80. Problem number 80. So it may not be continued, I think so. It's now raining here. We are getting a lot of air breeze. If AR is the coefficient of x to the power of r in 1 minus 2x plus 3x square whole to the power of n, then sigma r equals to 0 to 2n r times AR equals to, first option n times 2 power n plus 1, second option n times 2 power n minus 1, third option n times 2 power n, fourth option is n. This is the question, right? If AR is the coefficient of x to the power of r in the expansion 1 minus 2x plus 3x square whole to the power of n, then sigma r is equal to 0 to 2n r times AR we need to find out. This is also similar to the previous problem itself only. First expansion write down, and differentiate and substitute this time x is equal to 1 substitute, then you will get the answer. So let us try. 80 solution. So now sigma expansion r is equal to 0 means a naught, we won't get a naught. Sorry, r is equal to 0, right. Let us write like this. First of all, a naught plus a1x plus a2x square plus a3 x cube so on dash dash ar x to the power of r. Because ar is the x to the power of r coefficient, dash dash is equal to an x to the power of n equals to, this will be 1 minus 2x plus 3x square whole to the power of n. But we need to find out here what sigma r times r into ar. R take the values from 0 to 2n. Understood now? So that means actually here you will be getting 2n only. This is also 2n. I have forgotten. X to the power of 2n and 2n right down. So in order to get this, differentiate both sides with respect to x. With respect to x. So differentiate both sides with respect to x. What do you get now here? A naught differentiation is 0. Here you will be getting a1 plus 2a2x plus 3a3 x square plus so on r times ar x to the power of r minus 1 plus 2n times a2n x to the power of 2n minus 1 differentiation. This is n times 1 minus 2x plus 3x square whole to the power of n minus 1 into differentiation of 1 minus 2x plus 3x square differentiation. So we get minus 2 plus 6x. Now substitute x is equal to 1. So a1 plus 2a2 plus 3a3. That means you will be getting sigma r times ar. R is equal to 0 to here 2n value you will be getting n times 1 minus 2 plus 3 because x is 1 whole to the power of n minus 1 minus 2 plus 6. This equal to n times, this is 2 to the power of n minus 1. This is 4. 4 means 2 square. This is n times 2 to the power of n plus 1. First option is the right option. First option is the right option. Right. First option is the right option. So what is the question number now? 81, I think so. 81. (81) 1 plus x whole to the power of 15 equals to a naught plus a1x plus so on dash dash plus a15 x to the power of 15. Then sigma r is equal to 1 to 15 r times ar upon ar minus 1 equal to Here first option is 110, second option is 115, third option is 120, fourth option is 135. Right. See, this is actually, if you observe this one, this is nothing but r is equal to 1 means you can write like this: 1 into a1 by a0 plus 2 times a2 by a1 plus 3 times a3 by a2 and dash dash plus here n times an by an minus 1. So already we have done this problem, but instead of a1 we consider c1 c0 like that. This will be sigma n. Sigma n means actually here we can write n is equal to 1 to 15. So this equal to n times n plus 1 upon 2 at n is equal to 15. Substitute the value. 15 times 16 upon 2. 2 1 ja 2 8 ja. 15 8 ja is 120. So answer is 120. Third option is the right option. Eighty-two. Expansion of 4 minus 7x whole to the power of minus 2 by 5 is valid if first option x less than 4 by 7, second option x greater than 4 by 7, third option minus 4 by 7 less than x less than 4 by 7. Fourth option is minus 4 by 7 less than or equal to x less than or equal to 4 by 7. Okay. So now this expansion is valid. That means it should be put in the form of 1 plus x whole to the power of n, then mod x is less than 1. So here see, this 4 minus 7x raised to minus 2 by 5. Minus 2 by 5 is the rational index. Take actually here 4 common. If you take 4 common in the bracket itself, only 1 minus 7x upon 4. So raised to minus 2 by 5 you can write. So this equals to 4 raised to minus 2 by 5 and 1 minus 7x upon 4 whole to the power of minus 2 by 5. So it is rather in the form of 1 plus x whole to the power of n form. So that means here you consider mod x. Mod x is less than or equal to 1. Here x for you can take minus 7x by 4. Mod of minus 7x by 4 is 7x by 4. Mod is less than 1. That means mod x is less than 1 only, not equal to 1. Okay. Mod x less than 4 by 7. Therefore we can write minus 4 by 7. X lies between minus 4 by 7 and 7. Minus 4 by 7 less than x less than 4 by 7. That means third option is the right option. Problem number 83. A greater than 0, B less than 0, if the first first two terms in the expansion of 1 upon 1 minus x whole square plus 1 upon a plus bx whole square, or 2 comma 3x, then a comma b equals to first option 1 comma minus 1, second option 2 comma minus 1 by 2, third option 2 comma minus 1, fourth option 1 comma minus 1 by 2. Okay. So because actually I will take up to 545 or 550, because today due to the power failure somewhat disturbance is there. To compensate the disturbance, it will be continued for 10 more minutes. A greater than 0, b less than 0 if the first two terms in the expansion of 1 by 1 minus x whole square plus 1 upon a plus bx whole square are 2 comma 3x. That means first two terms of these two expansions we need to collect and equate it to 2 and 3x. Then we need to find out a comma b value. Okay, let us do it now. So 83 solution. So consider this expansions, we can write 1 upon 1 minus x whole square plus 1 upon, take a common means we will be getting a square common, 1 plus bx upon a whole square. So this can be rewritten as 1 minus x whole to the power of minus 2 plus 1 by a square times, this also we can write 1 plus bx upon a whole square. So we need to recall the formula for 1 plus x whole to the power of minus 2. This will be 1 minus 2x plus 3x square and dash dash infinity. And also recall 1 minus x whole to the power of minus 2. This will be 1 plus 2x plus 3x square, so on infinity, because we need these two basic formulae. Okay, let us find out now. Avinash, I already uploaded a video on the weightage on mathematics. Just refer it. So this can be written now 1 minus 1 plus 2x plus 3x square plus so on dash dash infinity multiplied with plus 1 by a square multiplied with 1 minus bx upon a 2 times bx by a plus 3 times we can write b square x square upon a square plus dash dash infinity. Now first two terms we need to find out. First term is constant term, next term is x 3x. So that means actually how to find out means 1 multiplied by this constant terms and next 2x multiplied by x terms we need to multiply. So that means See, you get first term. First term is equal to, you get like this, 1 multiplied by 1 by a square, 1 plus 1 by a square equal to, it's given that 2. Next second term is equal to, this is, we need second term is also 2x, sorry, 1 minute, I will tell you, we need 2x. It's okay. I will rewrite it. Wait now. So that means 1 multiplied by 1 and next 1 multiplied by this constant term. That's okay. Now we need x. 2x into 1 and next minus 2bx into 1. So this we need to multiply now. So we get now 2x into 1, 2x write down, minus 2bx by a, this is minus 2bx by a into 1, minus 2bx by a equal to how much given? That will be 3x given. So x gets cancelled, no problem. With the help of these two equations, we need to find out a comma b. Right. So here, see, 1 plus 1 by a square is equal to 2. 1 by a square equals to, you can write 1. Obviously, a square is equal to 1. And a is equal to 1. But actually plus or minus 1. But a is greater than 0. Yes. Okay. Now it is raining. I will stop after this question. A is equal to 1. We got a is equal to 1 since a greater than 0 given. Next we need to go for this one now. This we can write x, both sides x cancel, 2 minus 2b by a is 1, 2b equal to 3. Now 2b equals to, we can write minus 1, b equals to minus 1 by 2. Now you can check your answers. See, a is 1 and b is minus half. A comma b equals to, we can write 1 comma minus 1 by 2. So let us move to the question. Fourth option is the right option, not option 2. Let us check. Okay. Yes, 1 comma minus 1 by 2. Yes, correct. Eighty-fourth problem. If x is small, root of x square plus 16 minus root of x square plus 9 equals to, okay, first option 1 plus x square upon 24, second option 1 minus x square upon 24, third one 1 plus x square upon 48, fourth option 1 minus x square upon 48. Right. So now x is very small.